What is modal logic? Modal logic. Well, modal logic is simply an extension of standard propositional logic. We take propositional logic and add two new operators, the box and the diamond. These are unary operators, so adding the box or the diamond to any well-formed formula generates a well-formed formula, like so. And these are actually interdefinable. So box A can be defined not diamond not A, and diamond A can be defined not box not A. So we actually only need one of these, but it's helpful to have both the box and the diamond. Okay, so there are many modal logics. There are many kinds of modal logic. There are epistemic and doxastic logics that deal with knowledge and belief. There are deontic logics that deal with moral obligation, temporal logics that deal with times, and so on, just to name a few. But by far the most philosophically fruitful modal logics are the logics that deal with possibility and necessity, and these are sometimes called alethic logics, but they've so dominated the field of modal logics that most people just call them modal logics. So modal logic usually refers to those logics of possibility and necessity, but bear in mind that there are many more kinds of modal logics which have many useful applications. But in this series, we'll be dealing with possibility and necessity. I might touch on some other logics. It really depends where this goes. But certainly for the moment, my main focus is going to be possibility and necessity. And I should just point out that when I talk about possibility and necessity, I'm not talking about probability. In modal logic, we don't sort of say things like, oh well, there's a 30% probability of such and such, or whatever. We deal with brute necessity and brute possibility, and that's it. Okay, so let's get started. Our modal operators, we have the box and the diamond. The box means, it just means it is necessary that, or necessarily. The diamond means it is possible that, or just possibly. So here we've got necessarily P, possibly P. So these two statements here, they would be read necessarily 1 + 1 = 2, and possibly Frank doesn't wear brown shoes. Obviously, if you're dealing with formal logic, then you'll be seeing statements more like this. So here we've got not possibly P if and only if not P. Here we've got necessarily if P then Q, then if necessarily P then necessarily Q. Here we've got necessarily possibly P and not necessarily Q, and so on. I suppose one thing that it is important to bear in mind, the box and the diamond don't really mean necessarily and possibly. That's how we talk about them, that's how we interpret them for many purposes. But what we're dealing with here is a purely formal system. It does help to bear in mind that at the end of the day, these are just formal symbols which we can manipulate using certain rules. This is the box, this is the diamond, and we're going to interpret them as necessarily and possibly for the purposes of this video series. But that's all. And of course, it's the same with any other logical symbol. So let's think a bit more clearly about the concepts that we are dealing with here. Here's a list, or a sort of circle, of 5 fundamental concepts and how we might symbolize them. I've translated each of them into both operators. So let's take necessity. Let's say something is necessarily true, then it's not possible that it's not true, right? So if we take the statement 1 plus 1 equals 2, well, many people would say that it's not possible for 1 plus 1 equals 2 to be false. So it's not possible that not 1 plus 1 equals 2. You see, so that definition makes perfect sense. Necessarily not, possibly not. It's the same with possibility. If it's not necessary that something is not true, then it must be possible. It's not true, for example, that I don't know, that elephants are purple, but presumably it's not necessarily not true that elephants are purple. Elephants could be purple. It's possible. So you can see how those sort of equivalences work. Okay, impossibility. Well, if it's not possible that P, then it must be necessary that not P, because if it's not necessary that P is false, then P must be possible. Here we've got analyticity and contingency. This often relates to the analytic synthetic distinction, which is of course deeply controversial. But the basic idea here is that with, say, contingency, is that something is contingent if it's possible for it to be true and it's possible for it to be false. Again, you know, elephants are purple. It's contingently false. With analyticity, it must be either necessarily true or necessarily false. So it must be either necessary or impossible. You can consider sort of statements which are true or false in virtue of the meanings of the words. So the classic one is all bachelors are unmarried. That's true by virtue of how we define the words. So it's necessarily true. If you were to say all bachelors are married, then that would just be necessarily false. Or even there is one bachelor who is married, because it violates how we define the words. Or you can perhaps consider identity statements such as water is H2O. There might be other things that seem like water, but if they're not H2O, they're not water. So perhaps the statement water is H2O is one of these necessarily true or analytic statements. So hopefully you can see how analyticity and contingency work, and then I've defined it in terms of the other operator too. Okay, so I want to think about how these concepts relate to each other. So let's take necessity. Well, if something is necessarily true, then it must be possibly true. I mean, if something's necessarily true, it must be possible. Otherwise, how could it be necessarily true? So necessity seems to demand possibility. And obviously it also demands analyticity. And you can see that this is necessarily P. Well, analyticity is just defined as necessarily P or necessarily not P. So clearly it also demands analyticity. Possibility. Well, possibility requires either necessity or contingency. If something's, as I say, if something's necessarily true, then it must be possible. But it might, if something's possible, it might not be necessarily true. I mean, as I say, it's possible that elephants are purple, or indeed it's true that elephants are grey, but it's presumably not necessarily true that elephants are grey. That would be a contingent truth. So possibility, it requires either necessity or contingency. So I put those arrows in blue for the either or. If necessarily P, then possibly P. If something's contingent, then it's possible. Okay, contingency. Well, contingency clearly demands possibility, because you've got possibly P and possibly not P. That's how we're defining contingency. So that clearly demands possibility. But it actually rules out everything else. If you sort of look at that, if something is a necessary truth, then it can't be contingent. It clearly rules out analyticity. If something's impossible, then it can't be contingent. Impossibility, analyticity. This one here, analyticity, clearly requires either necessity or impossibility, and you only have to look at again, how we've defined analyticity, necessarily P or necessarily not P. So clearly that's either necessity or impossibility. And it rules out everything else. Finally, impossibility. Well, that implies analyticity, because if you've got necessarily not P, then you must have necessarily not P or necessarily P. But it rules out everything else. So so there we are. Those are some sort of basic relations between them. Of course, actually, I'm just looking at this. Obviously, if possibility requires either necessity or contingency, but if something is possible because because it's necessary, then obviously that would be the case of analyticity too. But anyway, just a couple of things to note. These two here are logical contradictions. They are logically contradictory. See, not possibly P, possibly P, necessarily not P, not necessarily not P. These two here, analyticity and contingency, are also logical contradictions. I'll point out, I think, it's worth bearing in mind